Hey, welcome back. So in those first lectures, you learned about the teaching team. We talked about some of the course logistics. In this video, we're going to get into how to program. And we're going to be teaching about the gentle introduction to Python that is Karel. So let's hop in. Meet Karel the robot. Now, I know you've already learned a little about Karel the robot because you needed to have some Karel the robot for your application. But in this class, we're going to start from the foundation and teach you everything you need to know about Karel from the ground up. There's a few reasons for this. Maybe you missed something in your application. And the other reason is we really want to teach you how to write some elegant Karel programs. Because as you learn, Karel can do some amazing things. But if you can write beautiful architected programs, you can have Karel do even more than you can currently imagine. So this is Karel. You've already gotten to know Karel a little bit. Karel looks a little bit like an old Macintosh. Karel has a leg that sticks out the bottom, another leg that sticks out the back. That's just the way it is. Karel is named after a Czech playwright who introduced the word robot to the world. And as you know, Karel is our first little robot. Now, Karel says good morning to you. And one thing I'd like to let you know is Karel was actually built to help people learn how to program. It was built in Stanford in the 1980s by this guy called Rich Pattis, and he invented it because he thought people needed a gentle introduction to control flow. And it turned out to be a fantastic idea. We've used it at Stanford ever since. Generations and generations of students at Stanford have learned their first steps in programming through this wonderful robot. And the idea spread. Great platforms like code.org and beyond use the fundamental concepts that Karel introduced to teach people how to program. Karel is a little robot who doesn't speak that much English. In fact, Karel speaks a different language called Python. Python is a programming language, and a programming language means it's a language that you can use to teach a computer to do interesting and cool things. There's a whole bunch of programming languages. There's Python, there's C++, there's Java. They all do very similar things, and they all require the same skill, that is how to program, what we call computer science at Stanford. This skill is really foundational. And in this class, we've designed the course to teach you the skill of programming. We happen to teach you in Python, but it wouldn't be too different if we taught you in Java. And in fact, if you learn how to program in Python in this course, it won't be too hard to switch languages later because at the end of the day, they're all quite similar. For this course, we chose the particular programming language called Python for a few reasons. One, it's become astronomically popular recently. It's popular for data science, it's popular for artificial intelligence, it's popular in universities, it's popular in industry. Lots of people love to program in Python. One of the reasons people love to program in Python is because it's designed very elegantly. And for that reason, it's actually great for beginners. So the other reason we teach Python is because it's a fantastic introduction to the world of computer science. It really is logical, it's straightforward, and it doesn't have some of the complexities that prevent people from learning when they're first getting started. So Python, it's the language you're going to be using in code in place. Do you know that Python was programmed by somebody and that person is still alive? The person who made Python is this Dutch programmer called Guido van Rossum. And in case you're curious, Python doesn't get its name from the animal. Instead, it gets its name from Monty Python's Flying Circus. Good times, fantastic show. We should all check it out. Now, Karel speaks Python. And you should get to know Karel. I know you know Karel a little bit more, but we should get to know Karel really well because Karel is a fantastic little robot. Karel lives in a world. That world is thought of as having orientation. We think of this side as being north, this side as being west, this side as being south, and this side as being east. Karel's world is a grid world, which means at any one point in time, Karel's at a particular cell, which you can think of as this intersection of a row and a column. Karel's world has some components. One component that you need to know about are walls. Karel can't walk through walls. If Karel tries to walk through one of these walls, Karel will create an error. Similarly, Karel can't walk outside of Karel's world because it's bounded by walls. Karel's world, as you know, also has beepers. Beepers we like to think of as small little tokens that emit a sound that Karel can hear only if Karel's on that particular corner. These beepers are things that Karel can pick up and put down. They're the markers with which Karel can think, and Karel can do some interesting computations. I have seen Karel do incredible things. I've seen Karel do incredible calculations. I've seen Karel play the game of Risk. I've seen Karel solve word searches. It turns out Karel can be an incredibly smart robot. But at the end of the day, Karel does all this only knowing 4 commands, but combining those commands in interesting and creative ways. Karel knows how to do 4 things when you open Karel out of the box. Karel can move, turn left, put down a beeper, and pick up a beeper. Why don't we go over those commands? What do those commands look like? Well, when you tell Karel to move, Karel moves 1 step in the direction that Karel's facing. So right now we think of Karel as facing east. So if Karel moves, Karel will take 1 step in the east direction. Boop, there you go. Move, not too complicated. One of Karel's other commands is turn left. And turn left has Karel rotate 90 degrees in the anti-clockwise direction or counterclockwise direction. So if Karel's facing east and you turn 90 degrees, Karel will be facing north. So if you turn 90 degrees, Karel ends up facing north. And if you turn left again, you'd have Karel facing west. And this looks a little bit like Karel's about to jump off into space. We'll talk a little bit more about that, but every time Karel turns left, Karel rotates 1 cardinal direction. So from west goes to north, or sorry, east goes to north. Karel can pick up a beeper. So if Karel is standing on a corner that has a beeper and you call pick beeper, Karel will pick up that little token, which is emanating sound. It goes into Karel's bag, and we think of Karel as now holding on to it. Karel's bag could have started with lots of beepers in it. In fact, most problems you imagine Karel starts with infinite beepers that Karel can put down. But anyways, Karel can pick up a beeper that Karel is standing on. First challenge I have for us is how can we put together the 4 commands that Karel knows? Move, turn left, pick beeper, and put beeper, so that Karel can pick up this beeper that's standing in front of Karel and put it on the top of this little ledge. So this first challenge I have for us is to get Karel to go from this situation to this situation. How could we possibly solve that? How can you put together the commands that Karel has to make this happen? Since you've already been through the application, maybe this is relatively straightforward, but why don't you think about it? While you're thinking about it, why don't we pull up a demo and see if we can do this all together? Before we jump into solving this problem, though, I want to mention one of the hardest things about Karel. One of the hardest things about Karel is to understand which direction Karel is facing. One of the reasons for that is you have to recognize that Karel is actually thought of as being looked at from a bird's eye view, looking down. At any point in time, you can think of Karel as being as an intersection, but it's kind of like you're looking at Karel from above, like it's a map where you're really far away. If Karel's facing east, Karel's in this direction, like you're looking at from top down. If Karel turns left, Karel's now facing north. And if you think about it from a bird's eye perspective, it was just an arrow pointing this way, which is turned left, and now it's facing this direction. If you turn left, it'll be facing this direction. So if you turn left again, Karel's now facing west. If you turn left again, Karel's now facing south. So think about Karel as if you're looking at Karel from top down, a bird's eye view perspective. If Karel's facing south and you move, Karel will move 1 step to the south. And so it's, again, just like that bird's eye view perspective. Okay, so your first challenge, can you get Karel to pick up this beeper and move to the top of this ledge? To solve this problem, I actually went outside and put down a Karel mat, and I set it up so that we can think about this problem 1 step at a time. So I wanted to search for a volunteer. Someone can help me solve this problem. And I figured, maybe we can all do it together. So I went to a little park near my house. I got this little water ball, which I called a beeper, and I created a mat that looks just like the world we're trying to solve. Karel is played by me. I had to volunteer for myself because everyone was sheltering in place. There's a beeper, and we like to pick up that beeper and put it on the top of the ledge. Let's think about this step by step. Well, first thing we do is move. After you move, you're on top of the beeper. So what can you do next? Yeah, you can pick up that beeper. So you can move and pick beeper. Then what? You can move. Then if you want to get to the top of the left, use your turn left. And then you can move. Now we should pause. At this point, what we'd really like to do is we'd like to turn right. But if you look carefully at your set of commands, Karel doesn't know how to turn right. Karel only knows how to turn left. So if you want to get Karel to turn right, how could you do that? You can think about this, but I'm sure you guys would come up with the answer, which is if Karel can't turn right, Karel could recreate the ability to turn right by turning left 3 times. So we can have Karel turn left. Come on, Karel, turn left. And then turn left. And then turn left. And we've now created turn right. Now we can move, put beeper, and move. Fantastic. Now, obviously, we don't solve problems often by going to the park and walking around on mats. Instead, we have to program our solutions into a computer. So let's see if we can go do that. I'm going to open up an interactive development environment, which is one of the programs where you can go code Python. There's a whole bunch of IDEs that you can use. IDE is for interactive development environment. There's the IDEs in your application. There's the IDE that we're going to be using in this class, which is built into Ed. And you can also get an IDE for your computer. All of these are just programs that are going to allow you to program Python. They're all basically the same, and Python is the exact same in all of these different applications. In this class, we're going to use the Ed IDE, and that means that no matter where you are in the world, no matter what computer you have, if it's got a browser, you will be able to program. So let's go over to the Ed IDE and let's try and solve this problem. Okay, so I've gone over to Ed. I've gone over to a lesson where I've got a problem created that sets up the Step Up Karel challenge, where Karel starts in the bottom left corner with a beeper in front of it, and Karel wants to get to this situation. Now, Ed Karel's purple, whereas the classic Karel is this Macintosh looking white and black, and that doesn't matter. They're both the exact same Karel. When you want to write Karel, you write a program in Python, and the Karel IDE in Ed has already got us started with some starter code. The starter code's got a whole bunch of things going on, but as you may recall from the application, we're going to be writing our code inside this thing called def main. So in def main, we can write our list of commands to solve this problem. So what do we want Karel to do? We want Karel to move. And don't forget that whenever you do a command, you have to put in open parentheses and close parentheses afterwards so that Python knows this was a command. If you have move, you can now run this program. You can see Karel moves, and that's it. Karel doesn't solve the problem, doesn't pick up the beeper and get to the top of the ledge, but now we've got a program that we can run. This is an IDE. It's a place where you can write Python code. So we can move, pick beeper, move, and then at this point, okay, we want to turn left, then move. And let's see if we can run this. So that big run button runs, Karel's going, and move, pick beeper, move, turn left, move. This is great. What do we want to do at this point though? You know, after you've moved, pick beeper, turn left, and moved, at this point, that's where we want to turn right. So I want to write something for humans to read. If I want to write something for humans to read, I can leave this thing called a comment. And comments are super important. They allow human beings to look at your code and understand what's going on. So we can say, I would like to turn right here. By putting this hashtag, everything after it's ignored. Similarly, if you put 3 triple quotes, everything will be ignored by the computer until it gets to another set of 3 triple quotes. These aren't notations for the computer, they're notations for other humans writing. This is crucial for the art of writing great programs. Great programs are not just written for computers, they're written for humans so that other humans can read the program and understand what you want to do so that they can build on top of it and make greater ideas. So I've left a note here for the humans to say, I really want to turn right here. So I can say, turn left, turn left, turn left. That'll have Karel turn left 3 times. And this comment makes it really clear that actually this is intentioned to make Karel turn right. So after Karel's turned right, we can move, we can put our beeper, and then we can move again. So we can reset and run this program. And you see Karel moves and does all these commands, puts that beeper and moves, and we've recreated the solution over here. Congratulations. Now, this is a pretty good program, but if we wanted to make it more elegant, how much nicer would it be if instead of having Karel turn left 3 times, we just had Karel turn right? This is way easier to read. You know, you don't have to get through this complexity of 3 turns left for a turn right. But the problem is when you run it, you know, it says, oh, there's a problem. Turn right is not defined. Well, you could give up at this point, or I could teach you how you could introduce new commands to Karel's vocabulary. Did you know you can teach Karel to do new things? You could teach Karel how to turn right. How would you do that, Chris? Well, let me show you. If you want to teach Karel how to do new commands, what you do is you define what we call a new function. After main, so main starts here and includes everything which is indented. So everything that's indented here is under main. After main, you can define new functions. And when you define new functions, you start at the no indentation level and you write def, and then you give a name. And I say, I want to turn right. After you've done this, you said, okay, Python, I'm going to introduce a new command called turn right. I write def turn right, I put the open close parentheses and I write the colon. Then everything that's indented is going to tell the computer, what should you do when you turn right? Well, I want to teach the computer how to turn right. And I know that if you want to turn right, I can use turn left 3 times to achieve the result of turning right. So you can turn left, turn left, turn left. If we change the speed of Carol and we make it really slow, we can see that now when we run the program, it moves, pick beeper moves, turn left, move. And when it gets to turn right, look what happens. It jumps to the definition and it executes each line. Then when it's done, it goes back to wherever it was called. Definitions, they allow you to introduce new commands into Carol. And this is a huge idea. This idea of introducing new commands is really the foundational idea of computer science. You can take the commands you're given and you can build something bigger and better. So no matter what programming environment you're in, you'll have a set of commands and you can define new ones to solve more and more interesting problems and to add cool new tools like turn right. So if we go back to the slides, we can talk about this a little bit. Key concept we learned while solving that problem wasn't just the 4 commands of Carol, but it was this ability to introduce new commands. We call this defining a new function. If you want to define a new function, you have to write def for define. You give a name to this new command that you're teaching Carol. You write open close parentheses, you write a colon, and then tabbed in 1. So with some indentation, you write statements one at a time, which are the commands that should be executed every time you want to do that new function. This is how you add a new command to Carol's vocabulary. And it's true in all of Python as well. Okay, so now let's go over an anatomy of program overall. If you want to write a Python program, there's 2 parts. First, you import some packages, and then you write your program. Let's jump into that program. What goes into a program? Well, a program has 3 parts. First, it has this thing called a main function. Then it has what we call helper functions. Then it has some code that tells it to start the program. The main function looks like def main, open close parentheses, followed by colon, and then the list of commands that will be executed when you start. Main is where the program starts when it gets going. It starts with main and it executes this 1 line at a time. And when it's done with main, it's done with the program. After you define main, where everything's indented 1, you can then define helper functions. Those helper functions can be as many defs as you want. You can def turn right, and then after you could have def turn around or def move to wall, whatever you want. You can define function after function after function, and it should look like functions defined after main. You can put them before, but by convention, we often have main at the top and then helper functions, ones that introduce new commands that would be used by main, would come after. So that's the anatomy of your program. You have main and then these helper functions. Now there's 2 other things I should mention. There's some code that starts your program. It looks a little bit wonky. It says if underscore underscore name underscore underscore equals equals, and then main with these underscores. What does that mean? This is basically Python saying, if this is the program that is being run, why don't you start with main? You don't need to really understand this in any deeper way other than if you put this code at the bottom, it becomes a runnable piece of Python. Another thing that I want to mention is imports. If you want to use something like Carel, or if you want to use a math library, whatever you want to be building on top of when you're writing your Python program, you import. And import is a fancy way of saying, I want you to go and grab all the code related to Python, Carel and bring it over here so that I can build on top of Carel. So for Carel, you would write something like from carel.stanfordcarel import star, and that brings in everything about Carel into your Python program. This is a complete Python program. It's written in one thing that we call a file. So in one file, you're able to write an entire Python program. Pretty neat. That is your very first Python program. Now, some terminology. This whole thing is called source code, and you might have heard coding or code, and it comes from this terminology of source code. This text which defines the program, that's what we refer to as source code. This part is referred to as a function. You know, the main is a function, and we think of it as doing something. This line of code, it gives the name of the function, and this one's saying that this function's name is main. This line of code gives a name to another function. This is calling it turn right. This is a function, and this is also a function. Whenever you have a function, a super important thing to know is that all the commands which make up that function will be indented 1. You know that these commands are part of main because they're all tabbed in 1. And that's very important. That's how Python knows what commands go within which functions. This whole chunk is called a code block. Anything that comes after a colon and is a sequence of commands, we call that a code block. So after that colon, everything should be indented 1. And you know that the code block is over when you stop the indent. There's a whole bunch of other code blocks. Anytime you see a colon and indent, that defines a code block. It's a chunk of commands that belong together. Okay, so that's all we've got for the first lesson. Now, of course, a lot of this you might have already known for your application, but really you just need some time to get going with the course. Get started on your assignments, get ready for your section, read ahead if you want to, and come back on Wednesday and we'll go deeper into control flow. And by Friday, we'll be writing programs that can make Karel do some incredible things. What a pleasure to be your teacher. I can't think of anything more fun. What a joy. Thank you guys so much. Can't wait for Wednesday, and I hope you guys have a great start to your week.